All right, everyone. Today we're going to talk about the chain rule. So it's the next of our derivative rules. And what it says here is that it's a method to differentiate a function inside another function. So if you look here, we're asked to take the derivative of f of g of x. Okay, so you can see here, hopefully, that g of x is resting inside of the function f. And the way that this rule is read is that it's f prime of g of x times g prime of x. The way I like to say that is that we kind of three steps for the chain rule. Okay, so the first is to take the derivative of the outside. Okay, then we keep the inside. And finally, we take the derivative of that inside. Okay, so looking at this first example, we first of all want to identify why we would be using the chain rule. Okay, so you can see here that we have a function, x squared plus 5x minus 3, that's inside another function. Okay, so that whole function is being raised to the fourth power. So this is a time when we would use the chain rule. All right, so what it told us to do was first take the derivative of the outside. Well, remember, the outside is this whole quantity. All right, so if this was x, let's say if it was a to the fourth, okay, how would I take the derivative? Well, you'd put the 4 in front. Okay, then we'd keep the inside, x squared plus 5x minus 3. We would decrease the exponent by 1. Okay, so that's the derivative of the outside. I used the power rule. I dropped my 4 down in front. Okay, I copied down what the base was, and then I rose it to an exponent that was 1 less than what I started with. Okay, now times the derivative of the inside. So the derivative of x squared plus 5x minus 3 is simply 2x plus 5. Okay, so now the last thing you want to do with this is just clean it up, and here you can tell that the 4 can multiply by the 2x plus 5. So you could multiply that through and get 8x plus 40 times x squared plus 5x minus 3 cubed. And there is no way we're going to expect you to cube a trinomial. Okay, so we're going to leave the answer like that. Okay, so looking at this next one, f of t equals 2 cos of 4t cubed. Okay, so last couple classes we talked about doing the derivative of sine or cosine of a single angle. Well, the angle in those cases were always just x. Here, okay, the angle is 4t cubed. So that is our inside, and the whole thing here is the outside. And 2 is just a coefficient. Remember, keep that in mind. Okay, so f prime of t. Well, what's it going to look like? All right, so first it told us to take the derivative of the outside. Well, the outside here is the cosine. So keep 2, that's your coefficient. The derivative of cosine is negative sine of the angle. So we keep the angle, that's the inside. We're keeping that. Okay, now times the derivative of the inside. Well, what's the derivative of the inside? 12t squared. Okay, and so now at this point, I want to see what can I multiply. Well, remember, anything that's not the angle, pretty much, okay, can be multiplied here. So the 2, the negative, and the 12t squared. So we would get negative 24t squared sine of 4t cubed. Okay. Okay, as we approach this third one, remember, we've talked about that we want to rewrite it always in order that we can see it, so we don't have this fraction, and so that we can recognize the powers very clearly. Okay, so I'm going to rewrite this as f of x equals, instead of having this 1 over 5x squared minus 7, well, that would be the same as 5x squared minus 7 all to the negative 1. And then that is all to the 5th. Okay, so if I rewrite it like that, then f of x, notice I'm not doing the derivative at all yet, I'm still cleaning it up, is 5x squared minus 7 to the negative 1 times 5 is negative 5. Okay, so we now, all right, are going to go ahead and take the derivative of this. And again, here we notice a chain rule. So you have 5x squared minus 7, that's your inside, and then the whole thing out here is your outside. Okay, so when I take the derivative, f prime of x, I first go ahead and do the power rule with the parentheses, if you will. So the negative 5 comes in front, keep our parentheses, and then this would become negative 6. So notice what I did here. The parentheses is like your x, if you will. Okay, but we're going to keep what's inside the parentheses. And now we have to take the times the derivative of the inside. So the derivative of 5x squared minus 7 would just be 10x. Okay, last step is to clean this up. So if you can see here, obviously we have a negative exponent. So when we have a negative exponent, and everything's multiplying, we're going to go ahead and draw our fraction bar. Okay, anything that's raised to the negative exponent is going to go on the bottom. So this 5x squared minus 7 is going to be 5x squared minus 7 to the 6 in the denominator. And then what's remaining in the numerator is the negative 5 times 10x, so negative 50x. All right, ladies and gentlemen, I want to remind you that as you're going through this, if this is just a little mind-blowing for you, if you're struggling with this, go back, pause, and rewind, okay? It's your duty to make sure that you're coming to class with an understanding of this. So if you are struggling or wondering where this came from, go back to the beginning and re-look at these, okay? Keep working at it. Don't just copy it down blindly. Okay, looking at this next one, g of x equals sine of 3x. Okay, so again, as soon as your angle is something other than just x, so if we have a trig function and then our angle is something other than x, that indicates that's the chain rule. Okay, so sine of 3x and then divided by 2x plus 5 to the fourth. So again, we have an inside and then we have an exponent of 4. Okay, so we actually are going to have to do chain rule with both of these, and we have a fraction, so that tells us it's the quotient rule as well. Now I want to show you something though. If I wanted to rewrite g of x, I could rewrite it, depending on my preference, as far as sign or product rule versus quotient rule. I could rewrite this like this, using a negative exponent. Oops, that's supposed to be a 4. And now I have the product rule. So either way, you're going to get the exact same answer. All right. And some students just really do not like the quotient rule. It's a lot to do. And so they like this one better. I'm going to go ahead first and do the quotient rule. And then I'm going to show you that, in fact, if I use the product rule, I would get the same answer. All right. So first I'll use the quotient rule. So g prime of x is equal to, all right, big fraction. We need low, so 2x plus 5 to the fourth. D high, so the derivative of sine 3x. Remember, we're using the chain rule here. So we have to take the derivative of the outside. Well, the outside is the trig function, which is going to be cosine. Keep the inside, times the derivative of the angle, which is 3. Okay, minus low d high minus high, so sine 3x, times the derivative of the denominator. Okay, so in this case, again, chain rule, 4 times 2x plus 5 to the third. So again, I'm taking that 4, pushing it in front of the parentheses, decreasing my exponent by 1, then times the derivative of the 2x plus 5, which would just be 2. Okay, all over low squared. So 2x plus 5 to the fourth squared. Okay, so now, if you remember, at the beginning of the year, we talked a little bit about factoring, and this is where this comes into play. So I want you to look here at your minus sign, and we have two sides. We have the left-hand side, and we have, all the way over here, and we have the right-hand side. okay, of our minus sign. And what we're looking to see is if there is any factors in common on the left-hand side and on the right-hand side, okay? And so you can see on the left-hand side we have this 2x plus 5 to the fourth, and on the right-hand side we have a 2x plus 5 to the fourth, okay? None of our coefficients, none of our standalone numbers are going to be able to be factored out, because here I have a 3, okay? Here I have a 4 times 2, which would be 8. They have nothing in common. But I can take out that 2x plus 5 to the, remember we take the lower of the 2, so to the third. Okay, now a big kind of bracket. All right, so what would be left on the left-hand side would be 2x plus 5. Okay, because remember you're dividing 2x plus 5 to the third away from 2x plus 5 to the fourth. So subtract the exponents, we get 2x plus 5. Okay, times 3 cos 3x. So I just moved the 3 in front. Okay, minus, here the entire thing canceled out. Okay, so this is all gone. And so what's left is 4 times 2, which is 8, sine 3x. Okay, all over. And now we have 2x plus 5 to the fourth to the second. And when you have a power raised to a power, we can go ahead and 2x plus 5 to the eighth. Okay, now the reason why this is helpful that we were able to factor that 2x plus 5 to the third out on the top is now, because it's a factor and it's multiplying times this big bracket, I can go ahead and cancel out 2x plus 5 to the third with 2x plus 5 to the eighth. So I'm going to go ahead and cancel that out on the top and decrease my 8 by 3 in the denominator, and so it would be to the fifth. All right, so my final answer here is g prime of x is equal to. All right, so I'm going to go ahead, and what's remaining in that bracket, I'm going to pull the coefficient out in front, the constant, so 3 parentheses 2x plus 5 times cosine of 3x minus 8 times the sine of 3x, all over 2x plus 5 now raised to the fifth. Okay, so that's our final answer using the quotient rule. Like I said, obviously we would just choose one or the other, quotient or product rule, but I would like to try it using the product rule just so that you can see it both ways. Okay, so now if we move forward and again take the derivative, but we've just rewritten it, like I said, as a product, so we can use the product rule instead. And again, this is just personal preference, what you prefer. Okay, so the product rule says first, so sine 3x, times the derivative of the second. So remember, okay, we're going to use the chain rule. So negative 4 is going to come out front. 2x plus 5. Decrease the exponent by 1. Take the derivative of the inside would be 2. Okay, so first times the derivative of the second plus the second, which is that 2x plus 5 to the negative 4. Okay, times the derivative of the first. So the derivative of sine 3x, remember we take the derivative of sine, which is cosine, keep the angle, times the derivative of the angle, which is 3. Okay, so now we have g prime of x is equal to, all right, so we are looking for a common factor. So we're looking on either side of our plus sign. Okay, so on the left-hand side of our plus sign and on the right-hand side of our plus sign, what do we have in common? And you can see the only thing that is in common with both sides is that 2x plus 5 quantity to the negative 5 and to the negative 4. Now remember, we take out the smaller power. So between negative 5 and negative 4, negative 5 is the smaller power. So we're going to take out 2x plus 5 to the negative 5, and then we have that bracket. Okay, so now we're dividing that out of each side of the, and trying to clean up as we go. So out from the left-hand side, if we go ahead and divide that out, well then it's going to cancel this whole term. And so what's left is negative 4 times 2, or negative 8, sine 3x. Okay, now on the right-hand side of the plus sign, okay, we can go ahead and cancel out 2x minus 2x plus 5 to the negative 5. We're going to divide that into 2x plus 5 to the negative 4. Okay, this means we're going to divide powers, we have to subtract the exponents. So when we subtract negative 4 minus the negative 5, we're going to get a positive 1. So negative 4 minus negative 5. Okay, so what's left then, I'm going to pull that 3 out front from over here. Okay, and we're left with 2x plus 5 to the 1, or we can just leave it like that, times cosine of 3x. All right, so that's my whole bracket. Now, last step is that negative exponent right here, the 2x plus 5 to the negative 5, that can go down. So 2x plus 5, and it's now to the positive 5. And what's left on top is negative 8 sine 3x plus 3 parentheses 2x plus 5 cosine 3x. And if you look at what we have up above and what we have here, you'll see that they are in fact the same thing. Obviously on the top it's reordered and the negative 8 sine 3x is written in a different order, but it's the exact same thing top and bottom. So whether you use the product rule or quotient rule, it's your preference. Okay, looking at this next one. Again, it's all about the rewriting before we take the derivative. Okay, so if I were to rewrite this, I would have y is equal to, we have the cubed root of 2x cubed plus 3t. So we would rewrite that so we could see the exponent is 2t cubed plus 3t all to the 1/3, because the cubed root is the same as to the 1/3. Okay, so now again, you can clearly see, here's your inside, okay, and the whole thing is being raised to the 1/3. So as we go ahead and do the derivative, we're going to have 1/3, pull that in front, okay, keep the inside, which is 2t cubed plus 3t, decrease your exponent by 1, so 1/3 minus 1, which would be like 1/3 minus 3/3, is negative 2/3, okay, times the derivative of the inside. So that's 6t squared plus 3. Okay, so now I just want to clean this up. And the reason we do this a lot is especially these are common questions on multiple choice, and they're never going to give you an answer with a negative 2/3, and they are going to clean this up. And so you want to be able to recognize the correct answer for a multiple choice so that you don't have the right answer on your paper but not be able to match it up. Okay, so this last step is really important to be able to see where things go, top or bottom. I have negative exponents, so I know I'm going to have a fraction. Okay, now this 1/3. Go ahead and put that stuff where it belongs. I know that I'm going to have a 3 in the denominator. Okay? And so now you're going to go ahead and take that 2t cubed plus 3t, and it's to the negative 2/3. So it's going to go down. And I'm going to rewrite this with a fractional exponent. This would be the 3rd root of 2t cubed plus 3t squared. So that's in the denominator. And then in the numerator, we have that 6t squared plus 3. Okay, now as I look at this, I notice I can do one last thing to simplify just one more step. I notice that in my numerator, I have a common factor of 3, which I also have a 3 in the denominator. So I'm going to go ahead and divide out a 3 into both of the terms in the numerator. Okay, so I'd pull out that factor, and it would be 2t squared plus 1 over 3 times the cubed root of this 2t cubed plus 3t squared. Now your 3's can cancel out, so our final answer is really y prime is equal to 2t squared plus 1 in the numerator over the cubed root of 2t cubed plus 3t all squared. Okay, this next one is another fun one. So h of x is cosine of x squared sine of pi x. Okay, so you have to recognize we have several things going on here. First of all, we have a product. Okay, we have cos of x squared times the sine of pi x. So that is the product of two functions. And then on top of that, we have chain rule for both of these because x squared is an angle other than x, pi x is an angle other than x. So as we take the derivative of those within the product rule, we're going to have to use the chain rule. Okay, so again, take it slow. And if you're not understanding, pause and rewind. All right, so h prime of x, using the product rule. We have first, which is cosine of x squared, times the derivative of the second. So the derivative of sine pi x, well, that would be cosine, because I take the derivative of the function, leave the angle, which is pi x, times the derivative of the angle. All right, well, what is the derivative of pi x? Remember, pi is just a number. If I were asking you to take the derivative of 3x, you'd tell me it was 3. So when I ask you to take the derivative of pi x, it's going to just be pi. Okay, plus, so that was first times the derivative of the second, plus second, which is your sine pi x, times the derivative of the first. Okay, so the derivative of cosine is negative sine, and then keep your angle, x squared, times the derivative of the angle. All right, so I can kind of rewrite this a little bit, h prime of x, but I do notice that there is nothing on the left-hand side. Oops, I should have stopped there. Okay, nothing on the left-hand side of the plus sign that is the same or in common with anything on the right-hand side. And so there is no GCF. There's nothing I can factor out, but I just can rewrite it just to neaten it up a little bit. Let's put that pi in front. So pi cos x squared cos pi x. And then we have, as far as the coefficients here, we have a negative and we have 2x. So we're going to do minus 2x sine pi x sine x squared. Okay, and that's as much as we can do with that one. Okay, the double chain rule, what's that all about? Well, sometimes when you're asked to take the derivative of a function, you're actually have a chain rule inside of a chain rule. So what am I talking about? Well, let's rewrite this first of all so we kind of have a picture of what we are talking about. So I could rewrite this as y equals, so I have cosine of 3x. And then you have this 5 up here, okay? We have cosine to the 5th power of 3x. So what that means is that you're taking the function cosine and you're raising it to the 5th power. It is not on this angle 3x. It's on the whole function. So we put a big parentheses and have it like that. So now when I rewrite it like that, you can see, okay, that we have inside, we have an inside, and we have this parentheses to the 5th. All right, now inside of that, your angle is not just x. So inside that, we have another inside. So that's how we have chain rule inside of chain rule. Okay, so as I work through this derivative, I want to keep remembering that I do the derivative of the outside, copy the inside, derivative of the inside. And we're going to have to do that twice, like I said. Okay, so first the derivative of the big outside would be 5. Okay, cos 3x. Decrease your exponent by 1. So that's derivative of the outside. Keeping the inside. So notice I kept the cos 3x, okay, times the derivative of the inside. So the derivative of cos 3x is negative sine 3x. So again, derivative of the outside, okay, keep the angle times the derivative of the angle. All right, so that's how we work through that. We did the derivative of the outside. That was this piece, okay, the 5 cos 3x to the 4. We kept the inside, then we took the derivative of the inside. Well, when we did the derivative of the inside, that's another chain rule. So as we follow this now, it's derivative of cosine, which is negative sine, keep the angle, and then take the derivative of the angle. All right, so finally, last step, I'm going to go ahead and clean that up. So I have 5. I have a negative 1, and I have a 3, which is going to be negative 15 cosine to the 4th of 3x, if I want to write it like that, and then sine 3x. All right, and that's my final answer. Okay, so our last example here is, again, one of these like symbolic problems. So we're going to go through and take our time, and we're given all this information at the beginning. that we're going to use at the end. If you see here, it says the function h is given by h of x equals g of x divided by f of x squared plus f of g of x. Find h prime of 0. All right, so we got to find h, first of all, prime of x. Okay, so how are we going to do this? Well, we have to break apart what we see. On the left-hand side of the plus sign here, we see g of x divided by f of x squared. That definitely is telling me quotient rule. Okay, on the right-hand side of the plus sign, we have f of g of x. That's chain rule. Okay, and actually, inside of our f of x squared here, we have another place where we're going to use the chain rule. All right, so let's break this down. So, h prime of x. So first we're going to go ahead and use the quotient rule on the left-hand side. So low d high minus high d low over low squared. Okay, so low would be f of x squared. D high is just the derivative of g of x, which is just g prime of x. So low d high minus high g of x, d low. All right, so when we take the derivative of f of x squared, first we would do the derivative of f prime, keep the inside, times the derivative of the inside would be 2x. So f prime of x squared times 2x. All over low squared. So f of x squared all squared. Okay, plus, all right, now we're going to do the derivative of f of g of x. So this is a direct chain rule, okay? So this is actually the rule from the formula at the very beginning of the video. All right, so we do derivative of the outside, which is f prime, keep the inside, g of x, times the derivative of the inside, g prime. All right, so that is our whole derivative for h. Now we're going to go ahead and plug in our 0. Okay, so this would be f of 0 squared, which is just f of 0, times g prime of 0 minus g of 0 times f prime of 0 squared, which is just f prime of 0, times 0, because 2 times 0 is 0, all over f of 0 squared. Okay, plus f prime of g of 0 times g prime of 0. All right, so left to right, let's plug in what we can find. All right, f of 0, we can see here is 3, times g prime of 0 is negative 2, okay, minus g of 0 is 4, f prime of 0 is negative 1. Okay, and then times 0. All over, f of 0 here is 3 squared. Okay, plus f prime of g of 0. So f prime of, well, g of 0 is 4. Okay, then times g prime of 0 is negative 2. All right, so let's clean up the left-hand side here. H prime of 0 equals, so 3 times negative 2 would be negative 6 minus, well, 4 times negative 1 times 0 is just 0 over 9. Plus, all right, we have one more substitution to do here. F prime of 4 is given as 2 times negative 2. All right, so negative 6 minus 0 is obviously negative 6 over 9. Negative 6/9, which if you divide top and bottom by 3 would be negative 2/3. Plus negative 4 or minus 4. I'm going to go ahead and write that 4 with a denominator of 3. So that would be minus 12/3. So my final answer is negative 14/3. All right, good job tonight. There's a lot of information here. So as I said, if you need to go back through and watch a couple of these examples again, please do it. Come into class ready to tackle some questions like this.